Hi, I'm Linda Smith. I'm in Psychological and Brain Sciences. My faculty collaborators are David Crandall, Chen Yu, Jason Gold, Rowan Candy, and actually an army of outstanding postdocs and graduate students who I've not cited. And actually, I'm not going to talk about the value of computer science or the fields. I'm going to talk about the value of other fields to computer science. My topic is computer vision and babies. So as many of you are well aware, the advances in computer vision, particularly with the advent of deep learning networks, the CNNs, has been going at an amazing rate, breaking one barrier after another, and problems that were considered intractable, from face recognition to finding and labeling objects and scenes, to robotic vision, to even hard visual problem-solving tasks such as Go. But there is sort of growing consensus and growing concern in computer vision that we might have reached the end of the big advances, that these advances are slowing down and that we are a bit stymied, okay, in our progress. So some examples might include, the failures of self-driving cars, or those cases that even when some CNN looks amazing, like you give it that picture in the middle and it says a man on a horse, tells you that's what they are, but it fails to tell you. It lacks nuance and intelligence. It fails to tell you that it's actually not a real man and not a real horse, that it's metal and a statue. Or a case, I gave that image right there to one of the top CNNs after it had been trained in its standard way, one that beats a lot of other networks at recognizing novel objects. And it told me that that was a silo. Construction buildings. Really? Oops. So a group of us at IU think it's time to bring in the babies. So the thing is 2-year-olds, human 2-year-olds, they certainly cannot drive a car and they will not beat anybody at Go. But they can do things that no computer vision algorithm can do. They are adept one-shot learners. By the time they're 2, if they see a face of Uncle Bob for the first time, they are going to recognize him again, even if his hair is a little off, from a different view, in a picture from when he was younger. And perhaps more remarkable, people think faces are special, is that by the time they're 2, they can learn a whole visual category from experience with a single object. So if you have a 2-year-old and they see their first tractor for the first time, a John Deere in a field, and they watch it for a while and Dad labels it, from that day forward, they will recognize tractors. This is well-documented everyday data and in laboratory experiments. They will recognize that tractor. They'll recognize any tractor, old ones, antique ones, new ones, lawnmowers, caricature ones in books, from that day forward, from one example, and they won't include tanks or trucks or other sorts of things. And the key thing, and this is also well documented, but I don't have time to go into it, the evidence shows quite clearly that this prowess in 2-year-olds is learned. It is learned by learning about faces, and it is learned by learning about objects. So the question is, how do they do it, and can you leverage that to smarter machine learning? So to get smart machine learning, you have 2 ingredients. You have the training data, and you have the algorithms into which you feed that training data. And the training data look very much like what I've shown you here. They're very typical examples of objects, lots of examples of many different kinds for each category you want to learn. Most people, when they're trying to advance computer vision, worry about the algorithms. But we think the answer is in the training data itself. And I'm going to give you data, I'm not going to go through this fast because I'm running out of time already, is from what's called the HomeView project. We put head cameras on babies from 1 month to 24 months of age, collecting data as they go, visual data as they go about their everyday lives. And we're working on those data and what it can tell us about better ways to learn to recognize objects and better ways for visual processing machine learning. And what the big difference is between the way babies, the data that babies operate on and the data that's used in most computer vision is that babies have a massive amount of data about very few, that's a typo, instances. And we believe this is what leads to one-shot learning. So for a 3-month-old, 15 minutes out of every hour of their waking lives are faces. But 90% of those faces correspond to just 3 people, mom, dad, and we'll say grandma. Similarly, a 10-month-old has tens of thousands of views in a single day of their sippy cup, close, far, upside down, occluded. Tens of thousands in a single day, day in and day out. Not all the cups in the world, but everything you might want to know about their sippy cup. Visual experience at the level of instances and the level of categories is extremely right skewed. They're learning a lot about a little. They also generate that input themselves in time by holding objects, by turning their heads. They select the sequences of trials that they are going to get. And that selection actually depends on their current state of knowledge. We believe this is the secret sauce to better machine learning. So what are we doing? Okay, here's what we're doing. We are showing that you can get better learning with better data. We right now have a number of papers and conference presentations that have shown that if you give standard computer vision models, baby head camera images, and baby statistics, they do better, and they particularly generalize better to novel instances. We are data mining the data from babies, the head camera images, using computer algorithms to ask what are the low-level to high-level statistics in these data. And our long-term goal is to get new and better algorithms inspired by babies. Thank you, and you can see the head camera movies from babies on my website.